Hi everybody, and welcome back to lesson 25 of the Dead Earth game development series brought to you by the Game Institute. I'm Gary Simmons, and in this lesson we are going to complete our feeding state. And it's going to be a pretty cool lesson because we're not going to have a lot of code to write, but what we are going to do is we're going to create a particle system that is going to emit some blood particles. And we're going to mount that particle system at the front of Jill's mouth, facing towards the rear of her head. So when she's feeding or she's biting, we can have some blood spray backwards in the correct direction. But we're going to implement this particle system and combine it with the rest of our systems in a way that the single blood particle system will be able to be reused by all of the zombies in our level. So we don't have to have a separate particle system for every zombie, which would be inefficient and I think overkill. Furthermore, other systems in the game that we develop later on are also going to reuse this particle system, such as when the zombie is attacking the player, we'll use it to emit some blood there around the player's head, and also when the zombie itself is taking damage from the player. Now, the particle system that I'm going to create is not going to be any type of work of art, guys. I'm going to warn you, I'm not very good at creating particle systems, okay? It's going to be pretty basic, and we'll probably want to swap it out for something much more cool later on. And in Dead Earth, I'll definitely go on the asset store and see if there are some really cool blood particle systems available very cheaply for purchase, which I'm sure there will be. So what we're really doing here is creating a placeholder and the code to support it so that at any point down the future, you guys or me can just replace that particle system in the scene with one that is much more visually pleasing. However, before we do any of that, I want to visit some of the states that we've developed so far, and I want to correct a few problems and a few bugs that have cropped up due to the asynchronicity of our pathfinding process. Now, you'll remember in the last lesson that I said that when we plot a path, it's asynchronous, so it means that we can have some of these race conditions where we're trying to head down a path that hasn't actually been calculated yet. And I also said that I'm sure a few of these would raise their head and we would have to address them as and when they do. Fortunately, Conrad Ferguson has helped me out a lot on the Dead Earth forum by pointing one of these such things out to me, where in Conrad's example he observed his zombie would sometimes miss waypoints on the waypoint network, just skip right over them, and it's due to the asynchronous nature of the pathfinding and the fact that we're not quite handling the wait states yet when paths are being computed. So I think it's probably best if I just show you what I mean, and I'll show you the exact piece of code that Conrad pointed out to you, as well as the fix that he suggested. I want to thank him also because it got me thinking about some of the other problems that we have that are due to the asynchronous nature of the pathfinding system. But let's start with Conrad's problem. So I've opened up our patrol script and I'm going to scroll down to the very bottom of the onUpdate function. You'll notice that just before we return patrol, we do this test that says, look, if our path has become stale, or if we don't have a path, or if a complete path was not able to be plotted to our target, in other words, our waypoint, then what we did is we simply incremented on to the next waypoint in the list. We gave up on that waypoint. The problem here is, and as Conrad pointed out, this hasPath boolean will actually be false not only when we don't have a path, but when we don't have a path yet. In other words, when the path is still pending. Now this means that with our current code, if, for example, up in our onEnterState function, where we first tell the nav agent to set a new path, if we find ourselves in the update function and the path hasn't been completed yet, let's say to waypoint 1, this code will be executed, we'll skip it, and we'll move straight on to waypoint 2. And of course, in a worst case scenario, if our pathfinding thread was really under load, we could have a situation where our zombies can't actually get to any of the waypoints because the minute they plot a path, they go into a queue, the path isn't completely plotted until, I don't know, half a second later or so. But at this point, we've already skipped on to the next waypoint, and then we do the same thing there. And our zombie ends up in a perpetual dream state, just running around, not knowing where to go. So Conrad's fix was simply to say that if we don't have a path, then make sure we also don't have a path that is pending, because if the path is currently still pending, then we don't want to do anything rash and skip on to the next waypoint. We only want to do that if we don't have a path and the path isn't pending anymore, because it means the A* search for a new path is now complete and we don't have a path. For whatever reason, the path couldn't be computed. So what we say is, if we don't have a path and the path is not pending, so I say zombie state machine dot nav agent dot path pending. And of course I have to change that to not path pending, okay? So if the path isn't pending and we don't have a path, then just bail from this waypoint and skip on to the next one. But if the path is pending, even if we don't have a path, then let's just wait and not do anything rash. So this certainly solved Conrad's immediate problem of skipping waypoints, but it did actually open me up to some other problems here, which is if we don't skip a waypoint when a path is pending, but then the rest of the code in our update function is still executing. And of course, more importantly, if we go up to our onEnterState function, it's in this function that we set, for the one and only time in this state, the speed of our animator. And of course we set that to whatever speed we configure for the patrol state in the patrol states inspector. So let's say, for the sake of argument, that's speed 2. So we know that even though we might not have a path yet, we have now forced our animator from its idle or alerted state into one of our motion states, either walk, jog, or sprint, depending on the speed you have set in your patrol state. So we also know that these states use root motion to drive our nav agent, which means that even if we don't have a path yet, our zombie is going to start running forward, but in what direction, God only knows. So I think what we need to do is make sure that if we're in the patrol state, and indeed the pursuit state, which we'll visit after, and we don't have a path, but the path is still pending, then really we just kind of want to wait where we are until the path is complete. But we don't have to worry about dropping back out of the state. We want to stay in the state, but just not go anywhere until we're ready to do so. And I think the best way to do that is, instead of setting the speed here in the onEnterState function, where for all we know we don't have a path yet, I think we should probably remove that line completely, and in our onUpdate function, what we would do is we will see if the path is pending. And if the path is pending, then we'll set speed to 0, otherwise we'll set it to that speed that was specified in our inspector. So what that means is only when the path is complete will our animator transition from whatever state it's in, either turn left or turn right or idle, into one of the walking states. And if for whatever reason along that path the zombie finds that its path is pending again, it will drop down into the idle state and wait until that becomes available before it starts moving again. Because if we don't do that and we just tell it to run forward anyway and just say, hey, for the next half a second while we're generating your path, just run forward, but we don't care where, well, then we're going to see our zombie sort of running into things. So where do I put this code in my onUpdate function? Remember, I've removed now from our onEnterState function that setting of our state machine speed. And well, I want to do it after we've checked and assessed all of the threats that may take us out of this state anyway. So I'm going to scroll down right underneath there, and I'm going to put this code above where we start trying to rotate Zombie Jill to face her target. So what I will say is if, and we have to get our zombie state machine's nav agent so that we can check if its path is pending, and if it is, then we will set the zombie state machine speed to 0. Otherwise, we should have our path, and we'll just set the speed like we always did to that value that we specify in the inspector, which is our private variable speed with an underscore. So now that we have this code here, what we can probably say is if the path is pending, once we've set the speed to 0, we don't really want any of this stuff to happen anyway. So we might as well just return from the function. And of course, we still want to return AI state type.patrol. We don't want to actually leave the patrol state. We just don't want to do anything in the patrol state yet until our path is complete. So we're staying in the patrol state in our state machine, but we're manipulating the animator so it goes back to the idle animation. It gets confusing, doesn't it? Because they're called states as well. We've got two state machines on the go here. So we will return AI state type.patrol. And of course, because we're going to return from the function now where we have a pending path, we also don't need that code anymore that we've just added that Conrad gave us, but we'll be using that in our pursuit state, I think. But we're never going to get here now if we have a pending path, so we'll put that back to how it was before, but we will use that fix from Conrad in our pursuit state. And I'll save that off, and now I'm going to go to our pursuit state. Now in our pursuit state we have a similar issue. When the pursuit state is entered, we set the speed immediately to whatever the speed was in the inspector. So we want to delete that line, I think, because we don't know if we have a path yet. In fact, when we come down here, the first thing we do is we set the destination of the nav agent. So the minute we get past here, for at least a short period of time, we definitely won't have a path. So we have all of this code at the top of our pursuit state where if we've exceeded our time, we return patrol. We want to scroll past all of the code that can transition us back into a different state, such as when we've reached our target. But I think here is where we have that same code before that didn't work, where we say if we don't have a path, then just return alerted. So we don't want to do that. We want to put Conrad's fix back in there, and we want to say we only want to drop down into the alerted state if we don't have a path and the path isn't pending. So zombie state machine dot nav agent dot path pending. However, we also want to do the other thing that we did here, because yeah, we want to drop back to the alerted state if for whatever reason we just cannot find the target anymore. The path isn't pending, but we don't have a path. But however, if the path is pending, then we want to set the speed of our state machine and thus our animator. Otherwise we have a path, so we should actually set the speed to what the speed is supposed to be for pursuit mode. So I think we want all of the rest of the code down here. I don't think it particularly needs to execute if we have a pending path. Is that true? Yes, some of it does. As you see, this code underneath what we've just added is the code that if the target is the player, we keep the zombie rotating towards its location. If it's not the player, but we're still on our way to the target, then we keep the rotation slurping to look in the direction. And if the target reached, then we return alerted. So all of these things we don't need to do if a path is pending, but these other things we do need to do, because this is where we check the current visual and audio types against our current target type and possibly switch to a new target or repath if the target is moving. So I think what we can do is we can literally just put all of this code here where we're rotating the zombie on the spot, and we can wrap it in a conditional that says only do this if the path isn't pending, and that's pretty easy to do because we've already got that in place, right? We can say if the path is pending, set speed to 0, otherwise, and we'll just say then wrap all of this in that code block. So this stuff only happens if we do not have a pending path, but the rest of the stuff where we do all the target checks still does. And I think that is our patrol state and our pursuit state done and dusted. Let me check it works. So she gets up. I suppose it's really hard for me to see if this is working because I wasn't really getting any race conditions anyway, but I just want to check I haven't broken it at the very least. So let's see her go to her next waypoint. Just check all this stuff works. Okay, so that seems to all work okay. The only other problem I want to fix before we get on with our particle system is one that hasn't really caused us any problem. It's in our idle state, which is the very first state that we wrote. And you'll remember that when we were dealing with our patrol, our pursuit, and our alerted states, we had that problem where if, for example, we didn't have a target, we would put it into the patrol state. And by going into the patrol state, if the next waypoint that we fetched wasn't within Jill's turn on spot threshold, it would then drop down into the alerted state to start her seeking left and right. But before it did that, because it had gone into the patrol state temporarily, she ran forward a little bit and it looked a little bit strange. And we fixed that by, instead of just forcing something into the patrol state, we would set its target and its nav path, and then we would drop into the alerted state and let the alerted state then make the decision to start going forward on the patrol route, or, you know, to start seeking left and right if that waypoint isn't within her threshold. But you can see if we go to our idle state, because when we wrote this, we were young, we were green, we were still shitting yellow, quite frankly. If you scroll down to the bottom of it, in the onUpdate function, you can see that we have a timer, and once the length of time that we're allowed to stay idle has been exceeded, what we were doing before is just going into patrol state, and it made sense at the time, right? Go into the patrol state, get a waypoint, start patrolling to it. But we now know better, don't we? That if we drop into the patrol state and the waypoint is behind us, then the patrol state is going to run us forward a little bit before it drops us into the alerted state, where Jill is then going to seek left and right. So we want to go into the alerted state straight away. But before we go into the alerted state, what we want to do is something we've done many times before, which is we want to get our state machine's nav agent and we want to set its destination to the current waypoint. We pass false in, we don't want to increment to the next waypoint, we just want to say whatever your current waypoint is, then set that as our target, set it as the path for our nav agent, make sure our nav agent is correctly following its paths, and then drop into the alerted state. And we know that if that waypoint is within Jill's view cone, she'll just go straight into patrol and there'll be no harm done. But if it's behind her or too far at an extreme angle, then it will start seeking left and right to acquire that target. So I think now, at least for the time being, we've fixed all of the immediate issues. So if we look at Jill now, let's just check that she comes out of idle correctly. Now that we've made that little tweak. She should actually go into the alerted mode for a little bit first. Very, very briefly, so you hardly see it. She went into the alerted mode for like a single frame. Okay, let's get on with the good stuff. Let's make that blood particle system and get some blood spraying around our level. So like I said, we don't want each of our zombies to have their own particle system. That would be inefficient and frankly it's overkill. What we want to do is add one particle system to the scene that all of our zombies and some of our other systems can use whenever they want to emit blood particles. So we'll have a single particle system, and when a zombie wants to emit some blood particles, it will simply say to that particle system, I want you to emit some blood particles right here at this location. So in order to add a single particle system to our scene, we go to the game object menu and we choose particle system. Now at the moment we can't see that particle system working because it is underneath the level, so I'm going to hold Control and Shift, and then if I move the particle system now by clicking on that square in the middle, it's going to snap the location of that particle system to our floor. Now we can see our particle system working. I'm going to rename that particle system and I'm going to call it blood particle system, like so. Okay, so we have one single particle system in the scene. How do we make all of our zombies access that particle system very quickly when they wish to access it? We certainly wouldn't want our zombie, whenever it needed to emit some particles, have to perform a lengthy search of the scene. Our scenes in Dead Earth will eventually be very complex, contain tens of thousands of objects, and that will be a significant search time. Now of course you could be saying, well, what we'll do is we'll do a search in the zombie's start or awake function. We'll do that search for that blood particle system just the once, and then we'll cache that reference and we'll be able to use it cost-free whenever we wish to. Well, yes, of course that would work, but when we have lots of zombies in the scene, that's going to be lots of zombies at scene startup doing a search through a very complex scene hierarchy, and it is going to add a significant number of seconds to the scene startup. And to be honest, I'm not just talking about 1 or 2 seconds. You could be waiting quite a long time, and we definitely don't want to do that. So of course another thing that we might suggest is saying, well, why don't we add a new particle system variable to ZombieJill's AI Zombie State Machine class. That way we would have a little slot in our inspector where we could drag and drop that blood particle system and she would have access to it. Of course, there's 2 reasons we can't do that. The first one is just more of a convenience reason. It's going to be a real pain in the ass if every single time we place a zombie in the scene, we've got to keep doing that drag and drop of the blood particle system. We're going to forget to do it from time to time, and we might not spot it that easily. But of course, there's another reason which totally rules that out, and that is we're going to want the ability to instantiate dynamic zombies on the fly. We don't want to always just abide by the rule that all of our scenes have to contain all of the zombies they will ever want to use at startup. Of course we're going to want to create them dynamically, and in order to do that we're going to need to prefab our zombies. And of course we would want to do that anyway, so we can very easily copy them into the other scenes with all of their inspector values intact. Of course, the problem with a prefab is it cannot maintain a reference to a scene reference, such as our blood particle system. And of course it can't, because prefabs by their very nature are scene independent. If we prefab OmniZombie Jill, we want the ability to be able to instantiate her in any of our scenes. So if we instantiated it in a different scene, what would it do with that reference to the blood particle system that existed in a very specific scene? So we can't do it that way either. What we're going to do instead is utilize the fact that all of our scenes are going to have their own game scene manager. And of course, our game scene manager, being a scene object, can maintain a reference to our blood particle systems object. But even better still, our game scene manager is a singleton, which means that our zombies can access the game scene manager very quickly. A search for that game scene manager reference will only ever be done once by the very first zombie that tries to cache that reference. So we now have a means where all of our zombies can simply access the blood particle system by saying game scene manager.instance.bloodparticles, for example. So before we start configuring our blood particle system, let's add that new particle system member to our game scene manager. So I'm going to open up the game scene manager in MonoDevelop, which remember is in our assets Dead Earth scripts folder. And you're reminded when we look at it in MonoDevelop, it's a pretty simple class at the moment. Yes, it's a singleton, but it currently stores a dictionary of state machines that our zombies are going to use. And we saw in Zombie Jill's Start and Awake sequences that one of the things that she does is she registers her state machine with this dictionary in the Game Scene Manager using her Collider ID, her Collider's instance ID, as the key. So that later on, when we're performing raycasts and collision tests, for example, if we find that a zombie's collider has entered a certain trigger, or a weapon has shot a round of ammunition and it has intersected this particular collider, we can very easily get from that collider to the state machine that is running that collider by simply doing the get AI state machine call and passing in the instance ID of the collider. But we're going to be seeing all that being used later on. For now, what we want to do is add a new member of type particle system. So I'm going to put that in my private members block. It is of type particle system, of course, and we will call this blood particles. And we'll set it to null by default because we're going to set this via the inspector. So because we're going to set it via the inspector, what we need to do is we need to serialize that field, obviously. There you go. I think actually what I will do is I'll move that around a little bit. I like to have all the stuff that's either public or being serialized, I like to have them at the top in a block so that I can see all of the inspector variables straight away. So I'll put a comment in there saying inspector assigned variables, like so. And of course we will want a public property so that any of our zombies or any of our other systems can access that particle system very, very easily. So I'll create a new properties block. I could really just make this public, to be honest, and then we wouldn't have the property function call overhead. But I don't want you C# purists ripping me to shreds for using a public variable, so I'm going to create a getter property for it instead. So this, of course, will be a public property that returns a particle system reference, and I will call this blood particles without the underscore, obviously. It's going to have just a getter, and it's going to return that reference to our blood particle system, which I call blood particles. And then if I save that off, oh, by the way, guys, I'm pretty zoomed out at the moment. So let me just zoom in so you can absolutely see what I've done. Okay, so right at the top of the class, I've added that needs to say serialized field anyway, doesn't it? I've added a private variable of type particle system called blood particles. And then down the bottom here, I've added my properties block, and I've called that blood particles, a property that returns a particle system reference, and it has just a getter that returns that private variable. And if I save that off and go back to the editor now, when we select our Game Scene Manager, we can see that our Game Scene Manager now has that slot where we can drag and drop a reference to our particle system. So let's do that. Cool stuff. So our blood particle system has now been already kind of integrated into our system. And we're going to see the Game Scene Manager used for many, many efficiencies like this. Okay, so let's do something with this particle system now to make it look a little bit like blood. So I think the first stage in configuring this particle system is we need to bring in a texture of a blood splat, and we need to create a material for it, an alpha blended material that our particle system can use so that it stops looking like an upside down snowstorm. Now, if you download the zip file that accompanies this lesson and you unzip it, say onto your desktop or whatever, you can see I've done that. This folder here called lesson 25 resources. Inside that folder is a folder called textures, and if you drill down into that, you'll see that I've supplied you with the texture that I'm going to use in this lesson of a blood splat. It's called Gary's faceblood.png, and I can confirm that this is an authentic blood splat, okay, because I actually got this texture by getting my girlfriend Kirsty to repeatedly smack me in the face until I bled, and then she took a picture of it with her high quality Canon camera. It's not quite as deep a red as I would like, because while she was doing that I did cry a little bit, so there's a little bit of tears mixed in with the blood, but I think it's good enough for what we need. So we need to bring this texture into our Unity project, and I think we're going to drag and drop it into that folder that we created many lessons ago, which is underneath our Dead Earth folder, and it's called Textures. It's currently empty, so it's just been waiting for this very moment to become useful. So I'm going to drag that texture into my Textures folder. Of course, it is a transparent texture. It has an alpha channel, so we need to tell Unity that. So selecting the texture, that's going to bring up the textures import inspector. We need to let it know that its alpha channel is to be used for transparency. So we click that little tick box, alpha is transparency, then click apply, and hey, there is our blood. So we need to create a material for that now. So let's go up to our materials folder, which is also empty and just waiting for its moment to shine, which is right now. And I'm going to right click and I'm going to choose to create a new material, which I'm going to call blood particles, like so. And I'm going to change the shader to one of the particle shaders that come with Unity. So we don't want to use the standard shader. We want to, from the shader drop down of the blood particles material, want to drill down into the particles subfolder, and we want to choose alpha blended, okay, so that the alpha channel will be correctly rendered, so that where the texture is transparent we will get no blood, and where it's opaque we will see blood. And of course, where it's partially transparent, we will also have it nicely blended with the frame buffer. So now that I've selected the alpha blended shader, you can see that the material inspector has changed dramatically to reflect the properties that that shader supports. So I think what we'll do is we will drill down into our textures folder and we will drag over our blood texture and assign that to the particle texture slot in the materials inspector. It looks very red, doesn't it? So I think we're going to want to change the color tint of our particles so that it's more of a kind of reddy black, because when you see blood in the real world, and yeah, like I've just told you, it's a fresh experience for me. It's not really that red. So I'm going to go with that for now, but of course we can tweak it once we start putting it in our particle system and seeing what it looks like in the scene. So going back to my particle system now, I'm going to select it in the hierarchy and I'm going to scroll down to its renderer component. So let's open that up, because that's where we get to tell it what material it should use for each of our particles. Now at the moment it's using the default particle material, which is this great big white ball here. We don't want that. We want to click on the material picker. That's going to bring all the materials up in our project. Can't be bothered to scroll. Oh, there it is at the top. I was going to say, if you have trouble finding it, just type in blood like so, and it will find, work just like a database search. It will just return any materials that start with the words blood, and we will double click that, and there you go. Job done. It isn't actually going to look a hell of a lot better than that, even when it is done. But that's okay for now. So I should mention at this point that when this particle system is in the scene, it's never going to be automatically emitting. I'm just leaving it emitting for now so that we can basically see what it looks like. So we're not really going to see a true emission, because what we're going to do in the actual game is that particle system is going to sit there not emitting anything, and then we're just going to say to it when we want to, hey, pump out 10 particles now please, and it will pump out those particles. So it's going to be a very different emission to what we're seeing now, but like I said, we're just using this to make sure we get the right direction and the right size of the particles. So I'm going to re-enable the emission. I'll just leave it on a rate of 10 per second for now, because that's fine. But we do need to change the shape, probably. I think we want the cone shape to be used, but we probably want to rotate our particle system and roughly move it up so it's near Jill's head, because we are really trying to get the right size for it now. So let's just sort of move it to her mouth, roughly. And because the cone shape that we're going to emit from, it's going to emit along the game object or the particle system object's z-axis, we really want to rotate it so that the blue arrow here, the z-axis, the local z-axis of the blood particle system, is sort of facing down Jill's head. In the actual game, we're going to, when we emit particles, we're going to move the particle system to a special mount that is going to be on Jill's mouth, but that's going to take care of the rotation anyway. But for now, we just need to make sure that we're seeing something that is roughly okay. So let me just rotate it around like so. We know it needs to be -90 on the Y. Is that right? Yeah, of course. Our cone is way too big at the moment. Let me just move it back a little bit. And I think the first thing we want to do is we want to make sure that the base of the cone is very, very small. So you can see I can open up the shape fold out here, which allows me to change all the different shapes of the particle systems. It can, emit from a hemisphere or something like that, which actually might be quite cool. I think for now I'm going to go with the cone, and you have an angle. We can set the cone angle to see how wide we wish it to sort of fly out from the base, but it's actually the base we want to change, because the base is very, very wide. We almost want it to be a point like that, so that the blood is coming from the mouth. 0.02, something like that. Yeah. And we probably don't want the angle to be quite as wide. I'll bring it down to something like 20. Okie dokie. So we've got it. You can imagine if that was mounted on Jill's face and she was feeding, we would see some blood spraying up. But obviously the particles are massive. They've got too much speed, and that's what we need to adjust next. So we do all that up here in the main blood particle system inspector. So let's start messing around with some of these values. So the first thing we'll do is we'll set the lifetime of our blood particles. This is how long they live before they're killed off and they're recycled and reused by the system. At the moment they're just set to 5 seconds, which is very uniform. So what we'll do is we will change the way that the lifetime is generated, and we will use a random between two constants. So I'll put the range something like between 0.3 and 3. And what this will basically do is it will make sure that when each particle is generated, they don't have all exactly the same lifetime. So not every blood particle lasts exactly the same amount of time. Some may be 0.3, 0.4 and die out very quickly, and some may last a whole 3 seconds before they fade out and become totally transparent and are killed off. So the next thing we want to do is alter the speed. So we'll probably set that down to something much less, like 1.2, something like that. Yeah, starting to look a bit better, isn't it? We can probably make that random as well. So we'll change the selection from a constant number to a random between two constants, and we'll say we want the speed to be something like between 1.2 and 1.8. So you can see some of them are coming out at different speeds. Next up, we need to set the size of the blood particles. Now, we definitely don't want them all to be the same size. So once again, we will change the way that the size of each particle is generated from a constant value to a random between two constants. See, it's already starting to look a bit better now, isn't it, in the scene view? And we'll start with something really, really small as the minimum, like 0.09, and then still something a lot smaller than that, like 0.39 maybe, something like that. Yeah, we're getting there. Just about. Okay, so next up we get to change the rotation of the particles when they're first generated, what's called the start rotation property. At the moment they're all created with 0 degrees rotation, and I think we want them all to be randomly rotated to try and break up some of that uniform look. So rather than just use a single constant value that would have them all oriented the same number of degrees around their axis, we'll change this to a random between two constants, and we'll just choose a value between 0 and 180. Like so. And now you can see they're starting to come out looking a little bit different, each of them. So we'll probably also want to have some control on making the colors look a little bit different. Now I know the material is predominantly the thing that controls what the color looks like, but we also have the ability to randomly tint it on a per particle basis. So we'll set the way the color is generated by once again choosing a random between two colors. And so there you go, I'll go with something like that for the colors, just white and red. It's very subtle actually, but it'll help a little bit, I think. So next up we can set the gravity modifier. We do want a bit of gravity. We want the blood to start to fall towards the ground. So if I say 0.15, is that falling towards the ground? Yes, it is. So that when it sprays up, it will start. Can you see it? I don't know if this is coming out in the video, guys, because I know, like, obviously they're quite dark at the moment, the blood particles, but you can see as they come out, they're falling towards the ground. But I think the gravity's probably a bit too strong, so maybe I'll say 0.1 for the gravity. Yeah, I think that might look a little bit better. Next up, we want to set the simulation space to world. I mean, it doesn't matter too much because we're going to be doing this via code anyway when we emit the particles, but it just means that the particles animate in world space and not in the emitter local space, so that when we move the emitter around, a particle that's already alive in the scene doesn't move to maintain its offset with the emitter. We definitely don't want to do that, because when we've got lots of zombies in the scene, if you imagine we had 10 zombies feeding at the same time, we'd be moving in a given frame that same particle system around to all 10 zombies and then emitting from each of those locations. So we wouldn't want, after we've emitted particles at the location of the first zombie, when we move the particle emitter, the blood we already emitted at that zombie moved with the emitter. So world space is what we want. So the next thing we want to do is we want to change the color over the lifetime of a particle so that it sort of fades out to nothing and we don't just see it suddenly stop. So we can do that by activating one of the modules which isn't currently active by default, which is the color over lifetime module. So if I turn that on, you can see you get a color picker. And if we click on that color picker, we have this color here where we can essentially set the color of 4 nodes. Now at the bottom here, we just want to leave this alone. This on the left hand side is the color at the start of the particle's lifetime, and this is the color at the end of the particle's lifetime. Let's just leave that alone so it doesn't mess around with any of the tints we've already set up. In fact, it probably has actually overridden the start color that I've set up here, but let's be honest, wasn't doing a great deal anyway, was it? But what we do want to change is the alpha, because we want it to become more transparent as the age of the particle is incremented. So obviously a white value in the alpha value is 255. So the left hand side, remember, is what the value will be at the start of its lifetime. And then what we'll do is we'll click on the node on the far right hand side, which is what it should be at the end of its lifetime, and we'll set that alpha value to 0. And you can see if I drag that over, the particles will begin to turn transparent much more quickly after they're born. But we probably want to do something, maybe something like that, I think. And next up, we probably want to have our particles rotating a little bit as they're flying through the air. So we will activate the rotation over lifetime module here, which we've done here. Now we don't want to leave this at the default, or all of our blood particles will be rotating at an angular velocity of 45 degrees. So what we want to do is have a random between two constants again, and we'll say something like between 0 and 90. There you go. So it's starting to look a little more organic now. Remember, we're going to be kind of behind the zombie when it's feeding, so we're going to see something like that. Okay, so I think that's about it for now. What we need to do now is deactivate the automatic emissions, okay? Because we don't want this thing emitting automatically. We are going to emit some particles via our source code. So I'm going to save that off a minute, just in case my power goes down. And what we need to do now is if I just move that particle system out of the way. Actually, no, let me put it back where it was, because I've sort of roughly positioned that. So what I can do is I can use that now to create the mount that is going to be on Zombie Jill's mouth, because it's more or less in the right position. So in order to do that, I am going to right click on the blood particle system, and I'm going to create an empty child. And of course, this will be in the exact same position and rotation of its parent object. So now I'm going to unparent it. Then we can just move our blood particle system out of the way. Anywhere in the level, we don't care where that is. Our code is going to move it. And I'm going to call this the particle mount. Now this particle mount needs to be part of Jill's hierarchy. It needs to be a child of her mouth bone, or at the very least her head bone, so that when Zombie Jill is running around, this mount is running around with her, and when she bends down on the floor to feed, the mount goes down with her also. And then in our code, we're going to move the blood particle system to the position and rotation of the mount to emit those particles. So where are we going to put this particle mount? Well, if we drill down into Omni Zombie Jill's hierarchy, then into our AI entity game object, you can see we have the root game object of the skeleton hierarchy called hips. Let's drill down into there. And then we're going to drill down into a spine, because that's where all the top half of her body is going to be. Drill down through all the bones, up through spine 2, into the neck, into the second neck bone, and there we have the head bone. And you can see there's actually, holy cow, there's actually a lot of stuff attached to the head bone. I guess that's because of all her eyebrows and stuff like that move. So what we want to do is we just want to drag our particle mount and put it as a child of Jill's head, along with those other objects. So now as we move Jill around, that game object will move around with her. But it wasn't quite aligned with her mouth, so we can probably now we've got it in her local hierarchy, we can probably just get it a little bit closer to where the mouth is. Something like that. That's good enough, isn't it? You can spend a little bit more time lining it up exactly. And in fact, I'm going to call that blood particle mount, okay? Just in case further on down the road we need to add other types of mounts to Jill that deal with particles, we'll know exactly what it is. And of course, all of our zombies are going to need to have a particle mount on them like this, but it's not as bad as it sounds, because you'll see later on that when we create different zombie prefabs, we can pretty much use Omni Zombie Jill as the template, and of course all the work is on the AI entity, and we'll also be able to leave that alone. And we'll just be able to swap out the hierarchy and the meshes underneath it. But we will still need to add, for each of our zombies, before we prefab them, that particle mount to its head bone. Okay then, so now we have our blood particle system in the scene, and we have the mount in Jill's hierarchy. It's now time to add some variables to our feeding script, so we can hook all of this up to our feeding state, and we can have our feeding state emitting some blood particles at the correct time. So I'm going to open up our feeding script, which is in our assets dead earth scripts folder, and then in our AI subfolder, and I'm going to open up my AI zombie state underscore feeding one script in monodevelop. Now the first thing that this script is going to need is it's going to need a reference to that mount that is attached to its head. And we can hook this up in the inspector and it will prefab find. And a script on a prefab can reference other game objects that are within its own hierarchy because they too are scene independent. So I'm going to create a serialized field of type transform, and I will call this blood particle mount, and we'll set that to null by default because, like I said, we're going to hook that up in the inspector in just a moment. Next up, we're going to add two variables which are going to control the emission of the particles. So we want two variables. The first one is how frequently we're going to burst some blood particles from the particle system. So if we make this a float and set it to, for example, 0.1 of a second, that means that we would do 10 bursts of particles per second. If it was 0.5, then we would be doing 2 bursts of particles per second. So this is another serialized field so that it shows up in the inspector, and I think I'll also give it that range attribute as well so that we get a nice slider bar. And I think we want to set this to somewhere between 0.01, which is way too low anyway, but gives us enough range, and probably a maximum of maybe 1 second. I don't think we want to be doing bursts any further apart than 1 per second, or otherwise that's just not going to look very good either. So that should be enough without having so much range that the slider bar becomes difficult to use accurately. And this is going to be a type float, and I'm going to call this blood particles. Actually, I'm going to change this to particles, not particles, so I'll change it to blood particles mount up above as well, and we'll call this burst time, and we'll just set this to 0.1 by default. And then the next serialized field we're going to have is how many particles to emit during each burst. So we'll use the range attribute again, and we'll set this to say between 1, which is obviously the minimum number of particles we can burst, to let's say 100. But I don't think we need to emit anywhere near that many particles, but let's just give us that control if we need it. Once again, it's a float, and I will call it blood particles burst amount. And I think in Dead Earth I actually used a value of 10, so I'll set that as the default as well. Okay, so let's save that off. Let's go back to the editor and let's hook up the reference to the blood particles mount before we do anything else. So if we select Jill's AI entity game object, we can now see that our feeding script now has those two sliders that we're going to leave as they are for now because I think they're pretty good defaults. And we're going to hook that blood particles mount up to that game object that we added to Jill's head bone, which remember is called blood particle mounts. Let's drag and drop that over there. Cool. Now our feeding script has everything that it needs to start emitting particles. So we're going to emit the particles inside the onUpdate function. So let's now scroll down to our onUpdate function and have a look at where we would put this code. Well, once we step past all of the threat assessment code, we have this little line of code which, you remember, does check to see if we're currently in the eating state. Remember, if we go back to the animator, we want to make sure that it is actually this feeding state on our cinematic layer that is currently activated. Now we've already got the conditional that checks that. You remember this from the last lesson. We get the zombie state machines animator and we use its get current animator state info function to see if the animation currently running on our cinematic layer is a match to our eating name hash, which remember is the feeding state. So we can put the emission code right in here. Remember, this was the code that we used to increase the zombie's satisfaction as it's eating. So as its satisfaction is going up, we will also emit the particles. And this will of course assure, if we do it in here, that we don't emit any particles prematurely in the zombie eating intro or the zombie eating outro states, where the zombie may not be on all fours yet, could still be in an upright position. So the first thing we need to do is we need to check that we have a valid game scene manager, that the game scene manager has a valid particle system reference, and that we have a valid particle system mount, this thing up here. So we will say in this code, if game scene manager.instance and game scene manager.instance.blood particles, and if our blood particles mount isn't null, well then we have everything we need to start emitting particles. So the next thing we want to do is see if it's time to emit some particles, because we have just added this blood particles burst time, and every time we emit some particles we're going to reset this burst time back to 0 and start counting up again. And in our case, once the timer exceeds 1/10 of a second, we're going to emit some more particles. So of course this state hasn't currently got a timer like we've had in other states, so let's create that now. That's going to be a private float. I'll call it timer. What else? and set it to 0 by default. And we'll also make sure that when we enter this state, we also make sure it's set to 0 as well. So I'll do that down here, and I will say timer equals 0, like so. And then of course, whenever we use a timer like this, we need to make sure that inside our onUpdate function, we increment the timer by adding on to it time.delta time, like so. And then down here, we can say if timer is larger than our blood particles burst time, then we know it's time to emit some more particles. But what we'll do is we'll create a local variable of type particle system and grab that particle system reference from the game manager, so that every time we talk to the particle system, we don't have to do game manager.instance.bloodparticles, because that is going to be pretty tedious. So I'll say particle system, and I'll call this local variable system equals game manager.instance.bloodparticles. So now we have a reference to the particle system. We want to move it to the location of our mount and also set its orientation to the rotation of our mount as well. Pretty easy. We'll say system.transform, get the transform of the particle system, and set its position to the position of our blood particles mount. Blood particles mount dot transform dot position. And likewise, for the rotation, we will get the transform of our blood particle system, and we will set its rotation equal to the rotation of our blood particles mount rotation. Remembering to get its transform, of course, and then use its rotation property like so. Now, although we set our particle system in the scene to use a world simulation space, it is possible that later on something else might use this particle system and may want to emit particles or put it into local space mode. So what we'll do is we'll just make sure that we definitely set the mode of its simulation space to world in our code as well. And we do that by saying system dot, and of course it was called simulation space, wasn't it, in the inspector. And we need to set this to a member of the particle system simulation space enumeration. And there's only two options there, local and world. So let's set it to world. Okay, finally, the particle system is where we want it. It's facing in the right direction. It's going to work and emit particles in the right space. Let's now just tell it to emit, and we do that by using the particle system's emit function. It takes a parameter, the number of particles we want to emit, which of course is our blood particles burst amount, like so. And finally, of course, we want to reset the timer back to 0 so that we can start counting up again until the next burst. So if we go back to the editor, check we've got no errors, and I have... Oh, of course, I know what I've done. I made the blood particles burst amount a float, which is silly because the emit function takes an integer because we never want to emit half a particle. So I need to set that to be an integer. I need to set the values that I sent into the range attribute to be integers as well. And I'll set its default value to 10. And now, obviously, the emit function won't have a problem with it because I am passing it an integer. I'll save that off, go back to the editor, check that the error's gone, and then we'll press play and we'll cross our fingers. And don't worry if the animations jump a little bit. What I'm doing to save some time is often when I'm waiting for Jill to get to the food source, I'm going to pause the video. So well, there's no point now. I spent so long saying that. She's now on her way to the food source. Okay, so let's see if this works. There you go. Look at that. Okay, it's a bit too much in it. Probably doesn't need as many particles, and the particles probably could do with being a bit smaller, couldn't they? So what I will do, I'll give them a shorter lifetime, I think, because they're going up quite a long way into the sky. So we set the lifetime between 0.3 seconds and 3 seconds. So I'll say the maximum is 1 second. And I'm also going to decrease the size a little bit to make it a little bit more realistic. So I'll set the maximum size down to 0.19. And once again, when I press play now, I'm going to pause the video so that we don't have to wait for Zombie Jill to get there each time, okay? Okay, here she comes. Okay, I think they're a bit small now, and I think that they're going up a little bit fast. I think they've got a bit too much velocity. So I'm going to budge up the size to 0.29, and I'm going to decrease the speed, which means I may want to once again ramp up the lifetime a little bit as well. Because they're not traveling as fast, they won't go up as high in the same space of time. So I'm going to ramp up the lifetime to 2 seconds of the particles, but I'm going to change the speed to... Actually, I've got speed between 0 and 1.8. We never want speed to be 0, do we? So I think we want the minimum speed to be maybe 0.3 and the maximum speed to maybe be 0.8. And let's see what that looks like. Although it's hard to see because the mount is sort of on, the camera mount is on her head at the moment. So when she goes down into the feeding state, she's upside down. But we can get a rough idea in the game view. You can see in the game view, that's not looking too bad, is it? Let's have a look. What's wrong? Okay, maybe we want to adjust the lifetime now a little bit more. Now that we've slowed it down, we probably can put it back up to the original 3. I'm just trying to get the blood a little bit higher up in the air before it fades out. And, you know, so we just see a bit more of the effect. What I did then was probably more accurate. You wouldn't see the blood spraying up, but hey, it's a computer game. Okay, I quite like that. That looks pretty cool. I mean, you can't really tell from the scene view, but if you look in the game view, I think that's going to be quite effective. So, okay. I was quite happy as well with the burst time and the burst amount, but just to check that it's working, let's select our AI entity, go down to our feeding state, and let's set the burst time to once every half a second, and set the number of particles down to just 5 every half a second, so basically 10 particles per second then. Here she comes, so this will be a lot less particles and a lot less frequent. Yeah, it's a bit understated that, isn't it? Oh, I don't know. It looks okay. I preferred it how it was before, personally, just because I think in the actual game when you're running around and you've got other things on your mind, not just studying the zombie, I think you're going to miss an effect that subtle. So once again, I'll go back to Jill's Inspector, and I will set that back to how I had it originally, which is 10 emissions per second and 10 particles per emission. So what we'll do now is just before we wrap up, we will bring another zombie in the scene that we can just very quickly pose as a dead body, just so that we can see the full effect. So let me remind myself of what I've actually got in this project. I'm going to go into my models folder, I'm going to go into my Mixamo folder. Well, I've got this kind of UK policeman here, so I think I'll drag him into the scene. And then what I'll do is I'm going to create temporarily a separate animator, because this isn't going to be an active zombie, okay? I'm just going to be using this as a dead body. So what I want to do is just give it a very simple animator that simply has a single state in it that just lies it down on the floor. And I think if I go into our animations, I do think I have a dead body lying on the ground somewhere. There you go, it's in my damage folder, and it just poses the zombie in that way. You can see it's literally just a single frame of animation that does that. So that is in my damage folder, inside my Game Institute folder, and the animation is called Dead, okay? Let me just check. I did definitely retarget that one to a humanoid, didn't I? Yes, I did. So it should work okay. So what I'm going to do now is I'm going to go back up to my Animator Controllers folder here, and I'm going to create a new Animator, or Animator Controller, as Unity calls it, and I'm just going to call this the Dead Body Controller. And in that Dead Body Controller, if I call up the Animator window, I'm going to, let me put it up there for just a second, I'm going to drag in, as its one and only state, that Dead Body animation, which is, remember, is in our Damage folder, and it's called Dead, isn't it? Like so. So now if I apply this animator to our policeman, as soon as the level begins, he should be put into that dead pose. And that's what I hope is going to happen. There he is, he's called Cop Zombie. So let me give him that dead body animator, like so. And let me just press play in the scene view and just check he does do that. Hey, look at that. He did indeed. So let's just rotate him around a little bit. And then what we're going to do is remember that sphere that we have here, which we're using as a mock food source. But we want to attach that food source now to the actual dead body itself, wherever we want the zombie to start feeding. Well, roughly. I mean, our animations are not going to be that accurate, so when the zombie kneels down, it may be intersecting the zombie, but I don't think it really matters. And there's probably ways that we can fix that later by putting either a collider or a nav obstacle on the other parts of his body, which would force the zombie around to the bit where the food source is. But for now, I think it's a bit overkill. We're just looking for the general effect. So I'm going to open up our COPS hierarchy, and I'm going to drill down into his hips, which is his skeleton, and into his spine again, which contains the hierarchy of the top half of his body, and on his neck, that's where I'm going to attach now this sphere that is our target, if you like, our food source. And I'm going to reset the inspector, and I'll make it a bit smaller as well because it's pretty big, isn't it? Like so. So now when the zombie falls down, because our food source is attached to the hierarchy, the food source is going to fall down with him and always be correctly placed at the location of the neck. So shall we see if that works? And here she comes. And you'll notice this isn't going to be very accurate when she stops. Actually, that's kind of bad luck really, because that turned out to be very accurate by sheer fluke. That does actually look like she's biting the neck. So let me run that again and see if I can get her to do a more typical inaccurate stop. Okay, here she comes. Hopefully she'll overshoot it a bit better this time. Not really. Come on, Jill. I mean, you can see that she has overshot the neck. She's actually eating the arm. Once again, it's not really too bad. It looks fine, but sometimes it can be quite a lot worse than this, and she can end up looking like she's chewing on his hand. And of course, there's not really a lot we can do about this, because remember, Jill is only going to transition into the feeding state when she enters her target trigger. And when she enters her target trigger, she's going to be pretty much at the point when she needs to go into this animation. But of course, there's going to be a transition of some duration before she actually stops and gets into that animation. At that point, she might have overshot. And of course, that's going to be worse depending on how fast she's going. So if you've got the zombie that is just walking around very slowly, like a Walking Dead zombie, then the overshoot is going to be minimal. And although I haven't really been able to demonstrate it here, because every time I actually press play, and I've tried about 10 times now, I can't get her to really overshoot badly. She can overshoot. Now, of course, one of the things that we put in our code to help with this is that we said that when she goes down, we're going to rotate her around so she's always facing the threat. So in this case, she would always be facing the food. But you'll notice that she didn't do that. And the reason she didn't do that is because we have the rotation code inside this block that says if we are not using root rotation. Now, here is where it can get a bit finicky with layers, because if we check any of our states here, we haven't added to any of them our, what was it called? It was called, that script we wrote, it was called the root motion configurator, which remember was where we were able to essentially reference count whether we wish there to be root motion or root rotation used. Now, we haven't added a script to any of these states, which basically means that root rotation shouldn't be getting used, but of course there is a layer underneath it that is playing. So although our cinematic layer completely overrides what's happening underneath, she's most likely on the idle state, and in the idle state we are absolutely telling her to use root rotation. So what's happening is when she goes down, she's essentially using the root rotation from the animation, which doesn't rotate her at all. We said that we wanted to rotate her on the spot to counteract these overshoot errors. So what we'll do is we will add a root motion configurator to our feeding state, like so. So we'll set root position to 1. We do want to use the position from the animation, but what we'll do is we'll turn off root rotation. Now, here's the thing. Remember, the root position and root rotation are reference counted, which means if we had root rotation set to 1 on the base layer and then root rotation set to 1 on the cinematic layer, internally, the reference count of our root rotation would actually be 2. Now, you're going to see later on that we are going to add several layers between the base layer and the cinematic layer, and they're all going to kind of override one another, a little bit like what you're seeing with the cinematic layer overriding the base layer. So we want to make sure in the cinematic layer, in this particular state, which is always going to be the kind of the topmost state, if you like, that overrides everything else, we want to make sure that if there is any root rotation set on any of the states underneath, that we definitely turn it off. And we can do that by just setting it to a very low negative number. So So if I say negative 100, that would definitely cancel out any root rotation. And of course, when we exit this state, 100 will be added back on, and it will just be set back to what it was before. And any layers underneath that required root rotation will have it. And you'll see that when I run this now, and now, before I run this, let me just preface it by saying that what might actually happen now is it might look worse, okay? But the only reason it's going to look worse is because when I was trying to demonstrate to you the overshoot, I couldn't actually get it to do it very well. But trust me, even though we're going to see it look worse probably now, and we may see the legs intersecting the body a little bit, it's not something that's going to really worry me. And there's things that we can do to address that and at least help nudge the zombie the right side of the body to begin with. So let me just run this and see if we are now getting our code in our feeding state correctly now, rotating the zombie to face the target. Actually, I don't want to be in game view mode, do I? We can't see nothing in that mode. Okay, so we should... Oh, come on, guide. There you go. So she goes down, and there you go. She's rotated on the spot now, so that her head is at the position of the threat. Now, like I said, you are going to get this sort of situation where you have the legs intersecting the body. Not really a lot we can do about that. Like I said, when you compare it to some commercial games like Left 4 Dead, and that I love, by the way, but some of the things they just, let their zombies get away with, I don't think we really have to worry about it. Like I said, it's just supposed to be something that's going to be happening very frequently, and the player will probably be running around the level kind of ignoring this for the most part anyway. But what we can do, I suppose, to give it a little bit of a help, is we could add a nav obstacle to the dead body's torso that will hopefully kind of nudge Zombie Jill to the other side of the zombie. So if I go down into the Copper's hierarchy, go into his hips, which is the skeleton, go down to his spine, and then add a nav obstacle component, nav mesh obstacle component, should I say. And I'll set this to a capsule. Should I set it to a capsule, or should I set it to a box? I'll set it to a capsule, I think. And I'll move it down a little bit to say something like that. And maybe I'll even up the radius a little bit, so that hopefully when Jill comes round, when this thing is led on the floor, it will hopefully bias Jill to sort of take the path to that threat around the outside, but we'll see. It may not work. So let's see what happens. See if it makes any difference. It may not, because we are overriding the rotation anyway at this point, aren't we, in the pursuit mode? Although we are following her desired velocity, aren't we? So it might help. There you go. It kind of did help a little bit, didn't it? It just helped nudge her to the right side. Let me just check that works again. Yeah, it should work because we're using desired velocity, and desired velocity will actually factor in the obstacles in the scene. If we were just facing her towards the target, then it wouldn't. But because we're following the desired velocity of the nav agent, when we're rotating our zombie, it should basically steer her in the right direction. You'll see that for the most part, that's gotten around the problem. Now, obviously, this doesn't have to be a dead body. This could be a pile of debris on the ground or whatever. But when we place these things in the scene with nav obstacles and with these food sources, we can pretty much minimize the damage of Zombie Jill intersecting or overshooting the zombie. So I think that's our feeding state complete. So thanks for listening, guys. I will see you next time, where I'm pretty sure we're going to take a little step away from the zombie, and we're just going to put a player controller in the scene. Like I said, it's not going to be anything like our final player controller, because that's something we're going to be developing over a lot of time. But all we need for now is just a basic player in the scene that we can start to flesh out and start to use like a player in an actual game. Thanks for listening, guys. I'll see you next time, okay? Bye-bye now.